heard of Kotlin? How many of you use it? Okay, great. So there's also an activity going on today which is called the Kotlin Trail. So if you pay attention to some of the things that I show you here, you might be able to answer all of the questions, and if you do, then you get a scooter, an electric scooter. You have to take it with you. We're not going to ship it for you, but it's still a nice scooter. So Kotlin is a language that we created back in 2010, I believe that it started, right? And we initially targeted to the JVM, which is, as you know, what Java basically is running on. And at some point, we decided to also target JavaScript. Why? Because everyone else was targeting JavaScript, so we thought it's cool to target JavaScript. And then at some point, we also decided to do native. And what native did is give us the ability to target Windows, macOS, iOS, Linux, Raspberry Pi, embedded systems, and I could continue to write here. It goes via LLVM, so whatever that targets, we can target. Okay? So we use it for, mostly the reason that we created it was because we, at the time, we were using Java, and Java was, how many of you have ever played with Java? Okay, it's not very concise, is it? I mean, it's kind of very expressive, so to speak. No, expressive, it's kind of long. And we needed something a little bit more expressive, a little bit more modern, a little bit more functional, a little bit more nice. And that's why we created Kotlin, but it had to interop with all of the JVM stuff and all of the Java stuff. And then we've expanded it, so now you can do Android development with Kotlin, you can do embedded, you can do desktop development, you can do multi-platform, which is a new concept that we have, which is called multi-platform projects, meaning that with the same code base you can target JavaScript, JVM, native, iOS, etc. Okay? So what I'm going to show you today is basically an introduction a little bit to the language and some of the functionality that it has, and pretty much everything that I show you today is applicable to any target platform that you use. So the language is essentially the same, and then it comes with a standard library which again targets all different platforms, and then we have a bunch of additional libraries. One of them are coroutines, if you're familiar with the concept of coroutines, which I'm sure you are. So we have coroutines that target multiple platforms, etc. Okay, so how does it start? Like any program, it starts with a main function, and you have a print line that says hello and welcome to ICPC, right? So this is similar to, quite different to Kotlin as actually an object-oriented programming language with functional constructs. And that's how you normally present Kotlin to a group of people that do object-oriented programming. If you go to a group of people that do functional programming, what you say is that Kotlin is a functional programming language with object-oriented constructs, okay? So it really depends who you want to please, that's how you sell it. But it's not really a joke, because in a sense it is actually the case. So one of the things that we have in Kotlin is top-level functions. So similar to JavaScript, except in a good way, right? So you have these top-level functions that you don't need to have the classes, you don't need to have the objects and all of that ceremony to actually declare just a function. You can just declare a function as it is. And the top-level function main is essentially the starting point to the application. So if I run that, I basically get my application, I get my output at the bottom, and everything's great. Okay? Now we try and make Kotlin very concise, way more concise than Java. And how many of you actually have done any kind of enterprise programming, so to speak? Okay, so one of the things that you do in enterprise programming, or otherwise known as everyday programming, is create, for example, objects that represent data, right? So for example, I can have a customer, or I can have a company, or I can have anything that has a series of properties. In Java world, that's called a POJO. In C# world, it's called a POCO, which stands for plain old Java object, or plain old CLR object. And it's a very, very common operation. So for example, in Java, for us to write something like that is all of this, right? So essentially what this is basically a Java class, and it's been reduced, right? So you can see that basically this has all been collapsed. But essentially this is just a Java class that has a property called ID and another property called name. And then it has an equals, it has a hash code, it has a clone, and it allows you to do a whole bunch of operations. Now this could be a customer, it could be a data point, it could be anything you want. Essentially an object, the data object that you use to represent some values. So this is very, very common thing that you do over and over again when you're writing code. It doesn't matter what you're doing, whether you're representing data and algorithms, whether you are doing a whole bunch of other things. You have to have a series of properties, and then you have to have the ability to clone objects, the ability to copy objects, etc. And you know, if I were to write this in Java, well, my tool, my IDE, IntelliJ IDEA, could essentially generate all of that code for me. The problem is it doesn't maintain it for me. So if I add a new property, it's not going to take that into account. So how do you do this in Kotlin? So if I were to write a customer in Kotlin, I could just write customer Kotlin, and then that would essentially allow me to now define a series of properties. So I could say, for example, val ID integer, well, let's just say string, val var name string. Okay? So that essentially has done pretty much the same as you just saw in the Java code here, to a certain extent. So if I do a split vertically, and we'll put these side by side, you can see that this one I could be an int, right? So this one could be an int and a name, and this is essentially what I've done here. Now, this syntax, what this is saying is that I want you to create a class for me called customer Kotlin, and then it has two properties, ID and name, right? Now in Java, in order for me to do that, I have to first declare a private field, and then I have to create these properties to represent the same thing. So already I've cut down a bunch of code. I don't have to do this and this, I just do one of them. And this basically indicates it's a property. This again is a constructor in itself. Right? So it's saying that now when I want to create an instance of my class customer Kotlin, I pass in two parameters, which is int and name. So I don't need an explicit constructor that I have in Java either. And then the val and the var is essentially telling me whether the property is mutable or not. So val means that it's immutable. That means that once I set the value, it cannot set it again, and var means that it's read and write. Okay? All of that essentially in a single line of code. Now, if I want to have the hash code equals clone, all I have to do is basically add the data modifier here. And as soon as I have that, now I have all of that code in this single line. And the great thing about this is that tomorrow, if I want to add a new property, let's say I want to add a property of email string, that's it. I don't need to go back and change all of the code that does the equals or the hash code or anything like that. It's all there. Okay, and this is essentially something that you use daily, whatever type of programming you do, right? Data classes, representing data. So, that's one thing that we kind of try and make a little bit more concise in Kotlin. And then of course with the functions, we also do it the same way, right? So for example, if I have a function that's sum, and I say x int, y int, now this is essentially the syntax for sum function, and then I put the return type. So if you're familiar with the Pascal, this is very similar to Pascal. You put the parameter and then the type, and then the return type at the end. So this can be expressed also in a much simpler way, right? I can express this in a single expression, single line expression. So any function can essentially be reduced down to a single line or a single expression, right? And if you have a 4K monitor, it could actually be a single line because you've got like 3,000 columns there. So what I could do is, instead of doing this so explicitly, I could just represent this as x plus y, right? So if I can reduce any function to a single expression, which you can, whether it's a when statement, etc., which we'll see, I can just express it in a much more concise way. And Kotlin is trying to be very smart on type inference, so I don't need to be explicit about the types, right? It's a strongly typed language, so it's not like JavaScript or Ruby where it's loosely typed, dynamically typed. It's a strongly typed language. The difference is that I don't need to explicitly constantly say my type. So this function also provides us a whole bunch of new characteristics, which is, for example, default parameters. So now I can have a function with default parameters and then pass those different parameters in different cases. So if I come here and I say, for instance, sum, right? I can do sum 1 plus 2, or I can do, let's say, with three parameters, or I could just do, for example, let's say that I want 2 parameters to be defaulted, so y is also 0, I could do that with 1 as well, right? Now, if I want to do just one parameter, sometimes I want to be able to pass in a different one. So in this case, if I pass in a 2, how does it know if it's the y or the z? Well, by default, it uses the position. But if I want to do that as a z, I just write z equals 2, and then it would allow me to change the position. Which means that then I can have actual named parameters as well. So I can do something like this, right? I can have different parameters passed in different positions by just naming them. And then this little feature of the IDE, which says, gives me the parameter name, I don't need anymore. Because essentially, if my function has a couple of parameters, I can name them. If it has 10 parameters, refactor your function so it doesn't have 10 parameters, right? Because you don't want to have functions with 10 parameters. So the return type in functions in Kotlin is by default unit, right? So it's unit. So that means that it doesn't return a value. But in fact, it does return a value. In Kotlin, unit is an actual value. If you navigate to unit, you can see that it's an object. And what is an object? It's essentially a singleton, and we'll get to that a little bit later. But here, if I don't put the return type, it is essentially just unit. Now, this is an interesting thing that you could do, which is, for example, let's say that let's write some code here, up here, that I'm going to do throw, exception, something, okay? Now, what happens there is that this line, the IDE highlights for me, because it says, hey, you're throwing an exception, so this line, what's the problem with it? It's unreachable, right? I can't reach into this code. So you're never going to hit that code. But now if I take this throw exception and I put it there, and here I call functions, it doesn't highlight that, right? Why? Because it doesn't know that inside that function I'm throwing an exception, and therefore that code is going to break the flow of the code, and therefore it's not going to return. Because by default, functions return, and they return an object. So if I do O, that is actually returning a value, right? If I do print line O, that won't ever execute, but it does return a value, it returns a unit. So how can I tell the compiler that this function actually never returns? So we can try and rename it and say, never returns, right? I want to tell the compiler that that function never returns. So how do I do that? I say to the function that that returns nothing, okay? As soon as I say that the return type is nothing, that function now, the compiler knows that it never returns, and therefore this becomes unreachable code. So this is quite useful when you're trying to create flow in your code. And for example, let's say that one of the ones that we use internally for this is the to-do. So to-do is a function as part of the standard library in Kotlin, which if you navigate to, returns a nothing and throws a non-implemented error, right? So it's essentially a bunch of to-dos that you have all over your code. But the good thing is, it will show you that, and it will break the flow, and it will say that there is unreachable code here because there is an exception. Right, now, as I said, you can pretty much write everything in Kotlin in a single function and then have overloaded conditional parameters, you can have default parameters, etc. So that means that, again, if you were to compare this to something like Java, or many other languages, where if I want to have the same function with different input parameters, I basically have to overload it over and over again. Whereas in Kotlin, I don't need to do that. I basically just create a single function and pass in the parameters and then do the named parameters. Okay? Much cleaner and more concise. One other thing that I mentioned was that here you can actually create essentially everything as a single expression. I'm not generally recommending that you do that, but a lot of functions work well if they're a single expression. So how do we do that when we have, for example, conditions? So in a lot of languages, again, I'll show you an example with Java. Here I have some basic conditional code. So I have a string parameter, a variable called parameter, and then I check for the length of the arguments being passed in, and then I set the value. Now here what I'm doing is two things. First of all, I'm declaring a parameter, and I'm making this parameter mutable, right? Generally, you want to try and stay away from mutability, because mutability essentially can hurt you in the longer run. But I have no choice because I've had to set that value based on a condition because it is a statement. So in Kotlin, I don't need to treat statements as conditionals. I can treat them as expressions. Sorry, I don't need to treat conditionals as statements. I can treat them as expressions. So here I can say that the return value of the if conditional is the value that is assigned to the last line of that branch. So in this case, I say the value, if parameter equals 0, is 1, if it's not, if 2, if not, it's 70. And you can see that a branch can have multiple statements, but the last value, the last line, is the value of that return statement, okay? And if I do something like string, you can now see that this gives me a highlighting because it's saying that the return value is now no longer of type integer, it is cast to type any, which is the top level object in Kotlin. Similar to the object in Java or object in C#, you have object any, which is the type in Kotlin. So you should generally favor, when you're using Kotlin, you should generally favor using conditionals as expressions as opposed to statements. And the same thing can happen with when statements or switches, right? This is switch in C++. So here I have a when, and then again I can have treating that when as a statement, or in this case as an expression, and I can have a certain level of pattern matching in the when statements. In each of the cases, I can have ranges, I can type check, I can have an else branch, etc. So one thing again in Kotlin, which is a little bit different to some other languages, is I said that we have the concept of classes, right? And we have hierarchies as well. So if I say, for example, a class employee, and then let's say I have a class person, right? Now, a class person tries to inherit from employee, and it can't. Why? Anybody? I want to check if you're awake. It's going red. It's not allowing me to implement inherit from employee, because by default classes in Kotlin are final. That means you cannot just inherit from a class. You have to open the hierarchy. So you have to declare the class as open, okay? And then you can actually inherit from it, right? So, sorry, the employee class has to be open. There you go. So you have to declare the class as open to be able to inherit from it. Now, one of the things that you try and favor in Kotlin, again, is to not have these large hierarchies, because if you've done like development over the years, when you have to maintain a code base, you often end up with these long hierarchies that don't make sense anymore, right? Because I have object A that inherits from object B that inherits from object C, and then object D has a whole bunch of methods that are completely irrelevant to it, but it's there because of the inheritance model. And there's this pattern, or there's this recommendation, which is, you may have heard of, which is favoring composition over inheritance. So try and stay away from inheritance, favor composition. And the same thing is with Kotlin, right? But we also make it closed by default, because what we want to try and do is make you actually think about whether this is the right approach to the problem, whether you should be inheriting from a class. But sometimes you just want that class to have some functionality. So let's say, for instance, I have a main function and I have a string. So we'll say, for example, val message equals hello, and then I do message to uppercase. Now, to uppercase exists because that function exists on the class string. But if I want to do message to camel case, that function doesn't exist, right? So what are my options here? Well, I could take the string class, if it is open, inherit from it, and add to camel case. But that's a little bit inconvenient. Or I could create a function, right? I mean, in Kotlin, I could create a function that just says to camel case, like so, and then pass in the message. Yeah, I could come here and say, okay, create a function to camel case and pass in the message, right? But that doesn't follow the same flow as I have, which is basically invoking functions on my object. So what I could do is create an extension function. An extension function basically means that I can take any type and extend it with new functionality. without having to inherit from it. And the way to do that is essentially to take the type that you want to extend, put a dot, and then the name of the function. So as soon as I do that, now I have extended my string class to have a new function called toCamelCase. Okay? Now, given that this is now an extension, I have an instance of that object. So I don't need to pass in that object anymore, because I can reference that object using this, which is the actual value of that class that I have extended. And we combine this with a couple of other features in Kotlin, such as with infix. So for example, I can say string is same as, and then say value, string, and then this equals value. So this is essentially a comparison if one thing is the same as another. So now I could say hello is same as hello, right? But what I could also do, which would be a little bit nicer, is this. Okay? That looks much nicer, because now it feels like I'm just writing plain English in a sense. Okay? Ignore that that's red, let's just pretend it works. I'm joking. The way that that works is you basically add infix. So you can have functions, any member function or extension function, which is a member function, that has a single parameter. You can call it in infix notation by adding the infix prefix to it. And this gives way to some interesting things that you can do with Kotlin, which are DSLs, which basically allow you to now create strongly typed languages with refactoring support, with navigation, with all of the good things that you can have in generally dynamically typed languages just using Kotlin. So in fact, if we go to Google and we do HTML builders Kotlin, you can see that this over here is essentially Kotlin. That's all Kotlin code, but it's actually HTML, right? So I've created HTML, but with Kotlin. So this all compiles, it's statically typed. If I navigate to HTML, that's a function. If I navigate to head, that's a function. If I navigate to title, that's a property. All of these, oh, well, that's a function. You can have this one as a property. All of this is possible with Kotlin because of a few conventions that we have. And one of those conventions is, which we're going to get into now, is the concept of high-level functions. So you're all familiar here with high-order functions, no? High-order functions, yes? No? You should. Has anyone done Haskell? So you know what a high-order function is. Okay. So a high-order function is basically a function that takes a function or returns a function. So in Kotlin, we can have higher-order functions as well. So let's say that I have a higher-order function here, higher order, and I can say that this function takes, for example, an integer and returns an integer. Okay? Or we'll take two integers. Right? So that now is a higher order function because it's a function that's taking another function. So if I want to call this function, what I do is basically say higher order, and then I pass in any function that matches this signature. Do I have one? No, but we can create one. For example, the sum one. X int y, and then this will be x plus y. Right? So now I can say, okay, reference that function sum, and I pass in the sum as a higher order. Now the cool thing about this is great, but I have to actually define my function sum beforehand, but I don't want to do that, right? A lot of times I just want to pass in an anonymous function, or a lambda, and I say or, because I'll tell you the difference in Kotlin. So if I want to pass in a function that I don't have to define beforehand, I can just say higher order, and then x, y, x plus y, right? That essentially is how you define a lambda in Kotlin. This is the lambda. You see that it's very concise because I don't need to be explicit about the types because it's using type inference. I know exactly that the type is integer, integer, and the return type therefore is integer. Now in Kotlin we have a convention whereby if the last parameter to a function is another function, we can exclude it from the brackets. So we could do something like this. Right? which is somewhat nicer. But this doesn't look that great because I still have this brackets over here. But given that this is the only parameter to this function, these brackets are redundant. So now I have just higher order, right? So it feels like a little bit the same, but now I've gotten rid of the brackets and I've moved the last parameter outside. So what I could do now also is this function I can actually have on multiple lines, right? So now this moves away a little bit from feeling like a function and actually maybe feeling something like a language construct. And in fact, the majority of the functions that we have in Kotlin that you may think are language constructs are not language constructs. They're actually just functions. So for example, if you've done any kind of asynchronous programming, if you're familiar with C#, for instance, how many of you here are familiar with C# or some JavaScript? In C#, they've got hard-coded words into the language to deal with asynchronicity, which is async await, right? In Kotlin, we do not have that. Async await are just basically library functions, but they feel like part of the language. To give you an example, we have this concept in C#, which is called using, right? And what using does is basically use an object and then dispose of that object. It's kind of like freeing the object, right? So I can create a function called using, which takes an object, which is closable, means that you need to dispose of it. And then I can take a body, which takes no action, no parameters, and returns a unit, right? And then here what I can do is I can invoke the body, and then I can say finally, object, close, right? So now, if I have, for example, my object that is closable, let's say whatever that object closable is, right? You can't actually do that, but for the sake of argument. If I do using, I can now say with object, do what I want, and then automatically that function is going to take care of closing it for me. So it's going to take care of disposing it for me. And this doesn't feel so much like a function. It now feels like part of the programming language, because it's essentially just a top-level, higher-order function. Okay? So this now allows me to do things like DSLs. So for instance, here's an example of an engine, right? This is a class engine, which has a thrust, a cost, and an FDEC, which don't ask me what it is, but it has a CPU. So now here, you can see that I've created this kind of like syntax where I'm setting the properties of my engine in a language that I've created myself, which is basically a DSL, a domain-specific language. So I have engine, and I can set the thrust, I can set the mass, the cost, and the FDECU, I can set the CPU. So if you've ever done anything with like JSON or XML or anything like that to set configuration properties or values, you can now do this in the same language. You can just use Kotlin to create your DSL and then set the different properties. Okay? And this is all done with a bunch of things. First of all, the fact that I can represent lambdas that are the last parameters, I can take them outside of the brackets, I can do multi-lines, and a few other things, namely in this case, I can also create an operator invoke, which allows me to invoke an object. Okay. So, one other thing that we try to do in Kotlin is get rid of the concept of a null, right? You're all familiar with nulls, yes? Null pointer exceptions, whatever flavor of your language of the month that you're using, you have a no value. So in Java, that's quite painful, right? Here, for instance, I have a customer that can be null, so I have to check that it's not null. I have to then, if I want to call getName, I have to check if it's not null, and then I have to actually check for the value. In Kotlin, by default, you can't have nulls. So if I come to my code here, and I say val, or say var abc def, and then do abc equals null, it says no, you cannot have nulls. Null cannot be a value. By default, you cannot declare nullable values in Kotlin, which means that essentially, if your application doesn't have any nulls, you'll never run into a null pointer exception. If you want to, you can though. So for instance, I could say that this is of type string, which is still of type string, right? But it's still not nullable. But if I want to say that I can declare a value to be null, I add the question mark. And now that value can hold null. So then now it ends up that if I do, for instance, print line ABC length, that's going to give me a compiler error, because it's going to say that null is not allowed. This could potentially give a null pointer exception. So, of course, I would have to do if ABC is not null, and then have this code inside the check. Or alternatively, what's much simpler is just say print line ABC question mark length. So what this does is essentially say if it is not null, then call length. If it is null, then don't call length on it. Okay? If you want to shoot yourself in the foot, we've got a feature for that as well. It's called the double hashbang, right? So anytime you want to just say, oh yeah, I miss my null reference exceptions, put that double hashbang and you get it right back where you wanted it. Generally, you don't want to do that. And you might think, why did we have that? There are some very edge cases. How does that translate to real life? You see a whole bunch of people putting double hashbangs in their code. Because if you put that, you don't have to think about the nullability case. Okay, so to finish off, let me just show you one more feature of Kotlin 2. One of them is, I mentioned before, have any of you read the book Design Patterns by the Gang of Four? Right, that's kind of like recommended reading by everyone that's doing object-oriented programming. If you're doing functional programming, you probably don't read that, and you criticize people that do read it. Okay, that's how our industry works. But anyway, one of the patterns that we have in that book is the concept of a singleton. You're familiar with the singleton pattern, which means an object can only be created once, right? In Kotlin, to create a singleton is single, that's it. You just create an object. So whereas with JavaScript, you have objects and you don't have classes. And with Java or C# you have classes, and then you create instances of those objects. In Kotlin, you have classes, but then you also have objects, which are essentially single instance classes. So if you don't ever want to create multiple instances of a class, don't ever create a class in Kotlin. Just create an object. Okay? And in all practical effects, this works pretty much the same way, but it's just a single instance. The other thing is the type aliases, which is kind of useful. So the type alias in Kotlin is essentially awesome customer equals customer and customer. So now I say class customer. Okay? So main, and then if I say val customer equals customer. Okay? So awesome type alias now basically is what it is. It's a synonym to customer. So it's exactly the same as customer. In fact, at runtime there is no new type. It's still the same exact type. Right? And this is useful because sometimes what I can do is, for example, deprecate something. I can say, for example, deprecated and say customer is now awesome customer. And then I can say replace with awesome customer. Because a lot of times you end up with an API you have to deprecate. So if I were to do this without this type alias, what would happen is that I couldn't introduce awesome customer without deleting customer. And then all the people that are consuming my APIs, that code would break. What I can do is add a type alias, ship that code with the deprecated. Now when someone uses my API, they'll come over here and say, oh look, it's giving me a hint, and oh look, I can press Alt-Enter and replace it. And then in the next iteration, actually get rid of the type alias and replace the actual code. And this way you do like a migration in 2 phases that you do not end up breaking people's code. Type alias is very useful for that, and we actually use it ourselves often when we're doing changes with Kotlin, whether it's, well, most of the changes in the standard library. Okay, so with that, I know we started a little bit late, but I'm going to try and keep on the schedule. We're done. If you have any questions, please feel free to stop by our booth, which is the JetBrains booth and also take part in the Kotlin Trail, which you get that also soon too. Okay, thank you.